As we start topic 2 of chapter 12, keep in mind that our next class will have our last test. We will have one more section, 13.1, but that material will be included on the final exam, which will be coming up shortly. So, looking at measures of central tendency. A good example to start us off, a city issues these number of building permits over 6 months. So we have 6 scores in a sense, or 6 items of data. Is there a single number that would give you an idea of central tendency? And the answer is yes. One of the most common is what we used to call the average, but in this section we'll call it the mean. And here they're saying this mean, or the arithmetic mean, simply is the sum of all of these divided by the number of months in this case. And this symbol read X bar, which is the symbol for the mean, is what we use. Now, we also sometimes will use the symbol mu, the Greek letter, to indicate the complete population of something. Here we're only using a sample, so we use X bar. And looking at the general formula for the mean that we see down here, this symbol, kind of a funny shaped E, is the letter sigma, the capital letter sigma in Greek, which stands for the summation, or the sum. So the sum of our values would be all of the individual items added up till the nth power, or the nth value I should say. And then this is the formula. X bar equals the sum of x's divided by the number of items that were added together. So in figuring out the example above, we have our general formula. The mean is equal to X bar, the sum of all the items of data by the number of items of data. And it is done this way. All right, going on to example 1, finding the mean of a list of sale figures. Here again, it's not too difficult. You're going to add all of these together, and there are 8 items, and then this will give you the mean. It's nice to have something that's easy like this. Now, as we move into our next example, we're seeing another kind of mean, but this is what is called a weighted mean. So, for instance, here are some grades, and here are the number of units that were associated with the grade. So the units of credit associated with the grade, but then to find the grade point average, we need to keep in mind, and the protocol for doing it is multiply the number of units for a course and the number assigned to each grade, add these points, and then divide by the total number of units. So for an A, that's a grade point average 4, and there are 3 units, so 4 times 3 gives you the 12, and then following through, a C, 2 grade points, units 3, 2 times 3, 6, 3 times 5, 15, and so on. Now there are 14 units, and grade point average, the sum of that would be 43. So in this case, we would take our sum of grade points, 43, divided by the number of units, 14. So the grade point average is 3.07. That was rounded out. So for calculating grade point average, this is referred to as a weighted mean. That is, there is a weighing factor for each item that you're dealing with. So here is the formula for this. So what you would do for each data item, you have to multiply it by its weighted factor, and then divide that by the sum of the factors. And you saw the example above. And to further develop, the weighted means formula is commonly used to find the mean for a frequency distribution. How often is something where there is more than, let's say, just one in a category that you would have to multiply, again using the weighted mean when they use a W up here that is barred. And nothing like an example. So in example 2, finding the mean of a frequency distribution of salaries. So we see in the first column the actual salary of individuals. In this column, the number of individuals, and then their total salaries in that category. So here we're multiplying 8 times 12,000 across. So we get the total salary, and then the number of employees are our frequency. So we will divide the total number by, or total salaries, by the total number of employees, which gives you the average salaries of individuals in this business. Now, they're saying that in some cases, depending how you organize your data, we can have a company with 6 employees, or the owner and 5 workers. If you just took the 5 workers and divided by 5, you would get the average salary of workers as this. Now, if the owner were to include what he considers his salary, you can see that now from 18,000 to 46,000 as a mean salary, the inclusion of the owner's salary really shifted what we think of as the mean. And if we look at these graphs here, we can see that that really did a job and can really be, skewed, as we say. So the inclusion sometimes of data that's way out of what would the average be, this is referred to as an Outlier, and we'll look at this as we go on and see that you need to be careful what statistics is showing. And in our text they are describing when data is not typical, it lies a good distance away from the general grouping of items. The extreme value like this is referred to as an outlier. Since an outlier can have a significant effect on the value of the mean, we say that the mean is highly sensitive to extreme values. For instance, if I were to figure out the average of a class, should it include people that don't show up and will get a very, very low grade, or the ones that are really taking the class? And that's often what teachers do. They will exclude extreme values because they want to find what's the average or what is the mean of the active group. So we've looked at the mean, or the mathematical or arithmetic mean, the average. Another term that's useful when we go over statistics is the median. Now the median is what would be in the middle of the grades, or that's what I'm used to working with, or the data that you're working with, that is, once they are set up, well, let's go over the actual terms. You rank the items, that is, arrange them in numerical order from least to greatest. And again, as a teacher, I've done this over the years many times. Now, if the number of items is odd, let's say you have 5 items, or let's say 23 items, the number is odd, then the median is the middle item of the list. If there were 5, and let's say these were the grades, then it would be the middle item. So 2 on this side, 2 on that side, this is your median. And if there were 25 items, there would be 12 on this side and 12 on this side, and the middle item of that 25 that were ranked from least to greatest would be the median. Now if they're even, that is, there were 26 items of data, you would have 12 on this side, 12 on this side, and then you would have 2 in the middle. So it would be like 13 and 13. So you take this 13th number and this 14th number, and then divide that by 2. Add these, divide by 2, and that would be the median when you had an even number. But we'll see some examples. So in that small business, if we included the owner, we'd have the 6 salaries now listed. We would take the 2 in the middle, add those, divide by 2, and then this would be the median. So a much better representation than the skewed data of using this outlier. So in working these examples, the first thing you'd want to do is how many items are there? Well, here there are 7. Here there are 9. Here there are 6. So put them in numerical order rating them from lowest to highest, and then just picking out, if they're odd, the middle one. So 1, 2, 3, our 13 here would be the median. Now in letter B, are they ranked properly? No, you would have to put them in physical order, and again you're going to pick out the middle one. Now in letter C, again, are they in numerical order? Well, these would need to be switched around a little bit, and then you would take the third and fourth item, once they're ranked, not as it is here, average those, and that would be your median. And we see the work listed here too. So once reviewed, in letter A, there, the list is odd, so it's the middle value. In letter B, we put them in a rated sequence, the lowest to the highest, and since it's odd, the middle one is the median. Now, in letter C, again, we'd have to rank them, and then take our 2 from the center, average them, and then divide by 2, and that gives us our median. So we've looked at the mean and the median. Now, locating the middle item, the median of a frequency distribution, is a bit more involved. Here you have to find out the number of items in the frequency and add 1, and then divide by 2. Now this will give you the position, and you would have to lay them out as to the, if you had, let's say, 50 altogether, again it would be between the 25th and 26th, and you would find then the position of it. That would be the median. And we'll see an example. And we might take a look at this. When will I ever use this type of information if you're not a school teacher? Because we use it all the time. And here they're talking about drug and alcohol dependencies, an actual report in which we see the data put into a graph form. Here the red line indicates a brief interview, and then the blue line complete checkups. And we notice that there's a much higher percentage of people returning for treatment when they've had a complete checkup, and they ask some questions about it. And the answers are given down below. In example 4, we are going to look for the medians for frequency distribution. So in example A, we have our value, and then we have our frequency. So let's stay with the A solution. We arrange the work as follows. Here's our value, there's our frequency. So we're going to multiply these and get our cumulative frequency. Now our frequency, when we do our totals, is 20. So we go to our formula, 20 plus 1 divided by 2 is 10.5. So then we go to our where are we going to get 10.5? Well, here is 5, 11. It's going to be right in there. So we're then going to add a 4 and a 5, a 4 and a 5. Divide by 2, we get 4.5. So this would be our median, 4.5. Now in looking at B, these are our frequencies and our values. Putting them into a chart, we multiply through, we get a value then of 35 as the sum of our frequencies. So 35 plus 1 is 36 divided by 2, which will give us 18. So if we go through our cumulative frequency, the 18th item, so there is 18 right about there. We can then figure there's a number of 6s that appear at this point, 10 of them, so the median then would be 6. So in this weighted frequency, where there's more in a particular slot, once we get to our middle of that cumulative frequency, that would be our median. Now, it might be of interest when I do this as a teacher, and I'll have the scores of a test as 100, 90, 80, 70, and I usually put like ticks as to where the grades are, sort of like that, and then I just physically count, and then I'll say, oh, this is the middle here, and that was an 80. So there's different ways to do it. This is the mathematical way of doing it. Okay, there are a lot of M words used in this section. We had the mean for average, the median for the middle score, and now we have the mode, which is also involved in central tendency. Suppose 10 students earn the following scores on a business law exam. Notice that more students earn the score of 74 than any other score. There were 3 students that had 74. So the score that occurs most frequently is the mode. Alright, so an easy example here. Find the modes for each set of data. So as we look at example A here, find the mode, and we scan them and see we have 2 49s. That's the only ones that are repeated. So we say our mode is 49. Here as we look, we see we have an 80, let's look right down here, 80, 485, 485, and then we have 2 of these. So there are 2 sets that are repeated twice. So in a sense there's no single mode, but we say there are 2 modes or it is bimodal. Now in example C, as we scan the numbers, no number appears more than once. So here there's a list in which there is no mode. And then here we have them listed. Our scores are in ascending order, and we look and we see the one used most frequently is 8. So our mode would be 22. And again, if I had listed them out as ticks on a paper, I would see which is the greatest concentration. That would be the greatest frequency. So that would indicate the mode of 22 here. And again, we're looking to study central tendencies. What's sort of in the center? What does our data give us in support of a study, or what tendencies are happening? We'll look at some of these graphs here that are covered in a section we didn't do, and they show that sometimes there's a single central area, or they may be bimodal in their distribution, or in some cases we'll say there is no mode. And they give this in, again, section 12.1 we didn't do, but you can organize your data into a table and then study and see if statistically something is supported or can help you understand. And for example 6, they want us to look at this data and then find the mean, the median, and the mode. So a calculator with statistical capabilities would automatically compute the mean. That is, if you had a calculator, you could just plug in your items of data, add in each item. Otherwise, you'd have to add them in individually, then divide by 40, which gives you the sum divided by 40 is this. So this would be the mean. Then in calculating the median, keeping in mind your frequency was 40, an even number, so you take your two central items of data and divide by 2, and here you can see if they both were 33, your median will be 33. And then as you inspect your data, once you multiplied, you would see that 36 occurred 4 times and no other value occurred that often. You would get the mode of 36. Again, we're not doing all of the calculation. Each of these would take a number of minutes to organize and write out and evaluate, but you want to know the technique of doing it. Going on to symmetry in data sets. If we have bar graphs and we look at the display of our data, here we see basically uniform distribution. Now in this second one, and I'm surprised they don't use the word that we used to use, and that is, you remember the shape of a bell. and we talk about a bell-shaped curve, this would be binomial distribution. This is sort of like in the shape of a bell. This would be bimodal distribution, sort of have two bells there. And let's look at this word though, symmetry. Something is symmetric or non-symmetric. Well, we use this in biology when we refer to a person here. Oh, I'm not a very good artist, am I? That if you divide it down the middle and kind of folded the sides over to each other, they would sort of match up. That's what symmetry in organisms is described as, and we're looking for symmetry in our diagrams here. So things are symmetric, or nearly so, or not. So for these, there is a sort of symmetry. That is, if you folded them over a central line here, the sides would match. Going on to figure 10, we see here these are asymmetrical or non-symmetric distribution. Here this is skewed to the left. That is, here's your right, and as you go to the left, it's not very much. It's not symmetrical, and this is described as skewed to the left, where the lesser is on the left. Here this is skewed to the right, where again, less on the right, more on the left. And here again, not symmetric, but bimodal distribution, that you have a peak there and sort of a peak there. Again, these are just used to describe your data and may have statistical importance depending upon what you are studying. So they give a brief summary here of what we're studying in this section, measures of central tendency, and we'll let you read this. We'll then go on to some examples in our exercises as time permits. Remember, we're going to be having a test now on items from Chapter 10, 11, and this the next time we meet. So you want to have your homework up to date, and good luck.